In this example, we'll learn about how both to read and write data in both the CSV and Parquet formats using Dask dataframe. To start, we'll start a Dask client. This is optional, you don't have to do this, but it's useful to have a dashboard, which we're going to run on the left here. I'm going to split my screen, click on this link, bring that tab over here. This will show us what's happening as we do computations. So in our first set of cells here, we're going to create a random data set, and then we're going to store that data to CSV. You don't need to understand this code, it's just to create a data set that we're going to use for the rest of the notebook. So I'm going to go ahead and call the toCSV method here. So toCSV works just like the pandas toCSV function, except you can provide it with more than one file name. You can provide it with many file names. Optionally, if you want to, you can provide a name function, make those names a little more semantic. So here we're going to use dates as our file names. So that produced for us a set of files in the data directory. There's a month of data, so we have one file for every day in the month of January. And if we look at a little bit of one of those pieces of data, we see that it's a standard CSV file. This is a time series with one data piece per second, and a variety of columns for the ID, the name, and some floating point values. This data set is random, there's no particular structure to it. It's just representing some data that you might have. And again, there are many of those files, so here's another file. If we want to, we can read a little bit of that data with the pandas read CSV function, giving it one file name. However, we can also use Dask dataframe read CSV, which has the same API, but we can provide it a list of file names using stars for placeholders. This doesn't do any work yet. Instead, this creates a lazy data frame that might index into those data frames as necessary. Here we'll call head just to get the first few rows, and we'll see that they are the same as what we had for pandas. We also did a little bit of work over here on the left. We read a little bit of data, got a little bit of data out, and printed it. So that Dask dataframe object is lazy, and it wraps around all those CSV files. You can use it either with many CSV files or with large CSV files, and it will break those files up, or with many large CSV files. If you want to, you can also place in here protocols for things like S3 or Google Cloud Storage or the Hadoop file system. And if you have the libraries appropriate, Dask will find that data in the appropriate place. So moving on, there are a variety of options to the pandas read CSV function and the Dask dataframe read CSV function. We recommend that you look at them. There's sort of too many to go over here. If you're familiar with this function, you know there's tons of options here. Dask dataframe, because it uses pandas dataframes, supports many of the same options, along with some additional ones like block size. For example, if we note looking up above here, our column here looks like timestamps, but by default, neither pandas nor Dask dataframe will recognize them as timestamps. Here they're stored as strings in the object D type. This will be a little bit inefficient. So we can use the pandas parse dates keyword argument and list all of the column names that are date times, and we can hand that to Dask dataframe, and it will recognize that now those are datetime 64 objects. This will make things a little bit more efficient in the future. So if we do a simple computation, here we're going to group by the name column and compute the average of the X column. We'll see here the activity on the left of all of my 4 cores on my machine. It just took around 4 seconds. And note that most of the time there was spent in these green boxes. And these are pandas read text. This means the pandas read CSV function. We're spending most of our time parsing our CSV data. A relatively little amount of time in these purple and green boxes doing the actual group by aggregations of the group by name x.mean computation. Now if we run that computation again, we'll see that we do all of those same read CSV computations again, taking again 4 seconds. By default, Dask won't store data in memory for you. If you want to, you can call df equals df.persist. Then it will store that data in RAM. But by default, Dask is designed to recompute things in order to save on memory. Another option, rather than storing data in RAM, is to store on disk, but in a more efficient format. So we're going to suggest the use of Parquet. Parquet is a very well-known and well-appreciated binary format that makes access very efficient. Dask dataframe supports a toParquet method. We're going to call it now. So we have our data frame that we define by calling read CSV. This is going to turn right around and call toParquet. This is a common first step when you're accessing data, you just quickly turn it into a different format. We give Parquet a directory name. Here we're putting all of our data from January into one Parquet file. Although again, one Parquet file is just a directory that has many, many smaller files. These are not going to be human readable. We can't look at these like we could CSV files with the text editor, but they're going to be much more efficient. Here we're going to reload our data as Parquet. Again, we're not doing any actual work here. We're just creating a lazy computation. But if we do that same computation with this group by name, x.mean, we'll find that it's much faster. So our green blocks here, read Parquet, still take up a fair amount of time, but it's comparable with our group by computations. It's about as fast. So we've increased our speed significantly. Additionally, because Parquet is a column store, it's often very efficient to select out only the columns that you want. So in the read Parquet function, we notice that we're only using the name and x columns of our data frame. The other columns like ID or Y are not that useful for a computation. By specifying the columns ahead of time, we can reduce the total amount of computation. In this particular case, it doesn't make a big difference. I suspect that bringing out the text here is actually the most costly thing. But in real-world applications, this is often a huge time saver. So that's it. If you'd like to learn more, we recommend going to the Dask documentation under the Create pages. This will show you all the various ways in which you can read and write data frames today. For example, if you want to go to the toParquet method, you can learn lots of information about the various options you can use when storing data to Parquet, including compression, different kind of options between fast Parquet and Pyro, etc. So that's it. Please enjoy the exercises and enjoy.